The Bitcoin, Ethereum, and Blockchain Super Conference is coming to Dallas, Texas, February 16, 17, and 18 in 2018. If you know of a better way to get the latest insider knowledge about crypto, to hear directly from the top minds in this field, to interact personally with 800 fellow crypto lovers, hodlers, investors, miners, traders, developers, and founders, then I'd like to hear about it. If you don't, then you don't want to miss out. Register today for the Bitcoin, Ethereum, and Blockchain Super Conference. Go to bitcoinsuperconference.com and register today as a super early bird to get the lowest rates on tickets and hotel rooms. That's bitcoinsuperconference.com.
Welcome to Almost Here, Round the Corner Future Technology Podcasts with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost Here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hello, this is Richard Jacobs with Future Tech Podcast. My guest today has a great accent, a nice guy named Ian Smith, CEO of Gospel Tech. Ian, how are you?
Very well, thank you. Very well. And thank you for taking the time and getting me on. No problem.
Well, tell listeners, we always start out with the basics. Tell me about Gospel Tech. What does it do and what's it about? Tell me about Gospel Tech. What's the mission of it and what do you guys do?
Yeah, so basically my experience has kind of been in enterprise technology around data and kind of founded Gospel just over, back in 2016 with a view to bring, a platform to enterprise to be able to provide, highly secure and trusted transactions for distributed data. So Gospel is really the practical application of blockchain to, radically change the business's ability to distribute and interact with content in these kind of new distributed architectures, whether that's cloud or Internet of Things or collaboration with other businesses. Gospel's been built to support and enable trusted transactions in those new distributed models.
So what's an example of transactions that are having problems for lack of trust or need a trusted method in order to communicate back and forth?
Yeah, sure. I think if you kind of look what's happening at the moment, we're seeing these large-scale bulk data breaches. We're seeing businesses under threat from all sorts of different kind of cyber activity. Kind of news items are almost a function of legacy architecture. These enterprise businesses have effectively, over the last 20 years, built perimeterized and siloed environments, with virtual and physical walls, encapsulating their, IT assets. Those assets running the services that these businesses have been built on, right? And over the last, several generations of technology, that's served them very well. However, what we've started to see in the last kind of, 10 years is this increased concept of shadow IT as people kind of start to work around the limitations of those siloed architectures. So whether it be, emailing structured data, whether it be using, commercial or consumer cloud storage technology, whether it be human interaction to kind of plug systems together, we see this behavior that's there to get stuff done, but is outside of traditional governance. And from those behaviors, we start to see, a huge scale data leakage and breach. So whether it be an example of somebody emailing, office data or spreadsheet data through to systems, not interacting at a secure data level, the huge risks for businesses. And what it's tend to do is slow them down in terms of transactions, slow them down in terms of managing this kind of risk, and that just allows these new digital businesses and cloud era businesses to disrupt that whole enterprise space. So I think that because data is the fuel of all of these new distributed architectures, without the ability to trust in that content and trust in the actors around the content, everything just slows down and becomes very manual.
So it sounds like data is vulnerable much more so when it's in transit versus sitting somewhere, or is that not even the case? Distributed networks are so important.
I think it's interesting. I think that the, traditionally it was saying that the transit phase of data, actually the sharing process was at risk, and that's totally true. And there has been, encryption technologies and point-to-point encryption technologies have kind of been put in place to secure that. But what we've seen over time is that type of technology tends to degrade and kind of become a limiting factor. And also we see as much as side of, in terms of data threat, the insider threat as much as the external threat even within the traditional perimeter. So, when you look at the whole, look at the news articles going on at the moment, this kind of hub-spoke patching kind of methodology just clearly isn't working. And I think that it's an interesting point about transit versus, static location, just general storage. It's all at risk if it sits in an environment that isn't conducive to what that data is now needed for. And I think that that's why gospel and distributed solutions are going to become much more prevalent as we move into these highly distributed models where data is kind of outside of the traditional data center.
So what's an example of the environment you set up for a customer, maybe without giving away something proprietary, but how do you accomplish this?
Yeah, well, okay. So imagine some of our customers do a huge amount of kind of R&D. Let's just take a really simple example of kind of research and development where, businesses are collaborating on a single solution. So say there could be, transportation or manufacturing, and there's lots of different components kind of geographically dispersed who are all kind of working on data sets or who are collaborating on data sets and are kind of working together. Now, currently, that usually means there's different silos, different storage platforms, and the interaction between those businesses can be highly manual. So we kind of see, the lack of trust in digital transmission of data. We see, a lot of email being used for structured data, even like traditional methods like memory sticks and people traveling to different locations because, that R&D data in itself is the, highly valuable intellectual property of these organizations. And even when the data is actually being consumed and used between these organizations, in a lot of contemporary business relationships, there are elements of competitiveness as well. So there's a lack of need to expose your core IP even to people you're working with on a particular project. So there's a whole set of kind of trust issues around, how that data is used and consumed, how it may be used or stored in future. And, the traditional methods of kind of this prescriptive data sharing, which is maybe, once it's kind of sent, you've sent a bulk data set, which may only a small amount needs to be used, but once it's out, it's kind of lost. There's a whole set of risks on, the integrity, the where the data's come from, how it's been accessed, how it's been used, is it being used for the purpose it's been set for within the context of the relationship. So, there's a whole set of complexity which, we see as one of the key inhibitors behind this trend of digital transformation and, being much more collaborative and distributed as an enterprise. So what Gospel really does is it shifts the dynamic and focus to the data. It moves away from just trusting, securing the infrastructure, whether it be a firewall or whether it be a server or whether it be some transient component. What we do is we move the security right down to the data level. So Gospel itself can be consumed as a cloud service, or it can be deployed across these various businesses in a virtual or a cloud access kind of architecture. But essentially, what we build is a platform, a data platform that effectively connect the different applications through APIs on each one of these different business environments. Now, what that means is data can be placed on the platform in a highly secure encrypted format. It's being stored on a blockchain. We use a underlying enterprise blockchain architecture underneath Gospel. And what that allows is a very secure method of ensuring and guaranteeing the integrity and provenance of data, the identity of the actors who are consuming and using and reading and writing data from the system, but also it ensures trust because the IOs, and uniquely at Gospel, even for Read IO, we use the underlying consensus mechanism, the blockchain technology itself, which we've obviously developed for the specific enterprise data use case. So what we now have, we've moved away from this speculative, manual, point-to-point kind of prescriptive bulk sharing to holding all of this structured data on a distributed platform, which is totally secure, and to actually be able to access it, you need to first of all have all of your own internal enterprise, multi-factor authentication systems, which Gospel natively integrates into, whether it be LDAP or Okta or these kind of modern, biometric, identity technologies. And once you've passed that, you actually get onto a permissioned position on the Gospel platform. And even at that point, no data is actually consumable or usable, but effectively the data owner and the consensus algorithm, through various different conditions, can allow access or consumption of particular data in line with a whole set of conditions that are part of ensuring that that data transaction is totally valid. So it could be, for example, whilst an open request for an engineer and data and a certain machine's location that's been set up through various different authentication mechanisms, all of those points between a certain time frame, when all of those kind of points align, the encryption keys allow that data to be consumed or viewed by the target application, and that data be used for whatever business purpose is needed. So, this is happening, hundreds of transactions a second, all automated across the distributed Gospel platform.
Some proposed decentralized storage platforms like Siacoin, Filecoin, MadeSafe, et cetera.
Yeah.
Do you incorporate any of what they're purporting to do? Break up data into chunks, encrypt the pieces, store the pieces in a distributed way. It sounds like your solution is very different.
It is. So we don't have a concept of any coin. My and the team's experience are enterprise technology people. We have people who've worked for some of the largest, enterprise technology consumers and vendors on the planet. And kind of what we've identified is that, the need for distributed data is, totally essential if businesses want to operate quickly and securely with trust, right? And we are born from the enterprise data problem, and that's not a new problem. That problem's been around since HTTP kind of started connecting centralized databases into the distributed internet, right? So we're not purporting that this kind of new problem's occurred. This problem of trusted data and the provenance of data and the access and the speed of which that can occur across a distributed network is a problem that's caused many tactical infrastructures and many kind of manual engagements to kind of make things happen, right? But what we've identified is whilst enterprises and infrastructure people kind of totally get the elasticity of cloud, and they totally get the need for these, distributed architectures, and the business cases of, multi-tenancy make sense. The trust in, who's accessing the data, the integrity of the data, has things been tampered, how do you avoid bulk or data leakage, all these elements, they're totally valid inhibitors to these enterprise businesses moving forward. So we've taken a very elegant architecture of a enterprise blockchain derivative and applied it to that data problem. Well, I guess what we haven't done is we haven't kind of started with this like blockchain and kind of looked for a problem to solve. I've been building infrastructures all my career, and the team have kind of been engineering and building and selling these infrastructures all their careers, and we've kind of realized this problem exists, and finding that elegant distributed premise that blockchain has brought, and is certainly started to mature in the last 12, 24 months to bear against that problem is really where we are. We've started with the problem, and we're kind of developing the platform to give a solution to that. I think that in terms of ICOs and coins and the cryptocurrency application, it's really kind of not what we're doing as we speak. We're more interested in seeing the data on-chain as the actual asset itself.
Yeah, no, I wasn't asking about the token aspect of it so much as the way that these companies are thinking about storing data, breaking it up into pieces, encrypting it, putting the pieces on various different computers in an encrypted form.
Yeah,
you guys
are
using a permission blockchain, it's a bit different.
Correct. Yeah, no, so I guess interesting. So, yeah, we don't kind of see that disaggregation model of breaking into blocks and kind of highly distributed. I think for us, what it is around is using the consensus mechanism for, valid access and consumption of content. But also we've used the underlying transaction syntax as an ability to cleanse and classify data as we ingest it on chain. So there's a huge challenge. So we haven't gone with that kind of like granular effect. What we've gone with is essentially using the underlying ledger as an ability to create a common transaction syntax that's encrypted and totally secure. We've built our own, certificate authority and these kind of elements to give us, total assured security around the data. But, the actual ledger we're using, in terms of, storing those transactions for performance, for access, for performance on search. And, we've kind of built some unique things around balancing security and search against, encryption. We've built contextual access, so you don't even need to expose your underlying data. We've actually built distributed data logic around content that allows, rather than, for example, if you're looking at doing a valid transaction, say you wanted to do something where you had to expose your age, rather than actually expose your birth date, somebody could query Gospel contextual search against, are you over 21 years old, to get a valid transaction, and then you could achieve consensus across the nodes in the Gospel permissioned environment. So, we haven't chosen to disaggregate data as such. We've chosen to use our technology to cleanse and create a provenance of data within the Gospel platform that, you'd need permission to access.
What about transaction speed and capacity? Everyone seems to be running into a wall very quickly, that they can't do a lot, many transactions a second. How come you guys can?
Well, I think that, bear in mind, not all blockchains are the same, right? And, if you look at the Hyperledger platform that we've built off, there are elements of, world state that's held in, a traditional, more relational data structure or NoSQL data structure. There's various different states in which the data is held in that we can leverage in different phases of that data life cycle. What I'd say is, though, we've spent a lot of our initial investment time in ensuring the Gospel platform can perform when it comes to the type of I/O that we need. So say if we're up to, 2, 3, 4, 500 transactions a second, that's completely in line with what our platform can achieve, across, the kind of data use cases that we're doing. There's always going to be a place for relational databases, and, sub-millisecond transactions aren't what we're looking to address. They usually occur in very tight, secure, controlled, environments that are in memory and by their nature quite centralized. So, the nature of the type of I/O that we're addressing is distributed, and, we are focused on those use cases that sit within that, performance capability that we would currently align to.
Do you see any barriers to transaction speed?
Oh, I would.
That wouldn't be satisfying for enterprise. That would.
Interestingly, that what we would say is that we cut a block every 4 seconds, right, on our Gospel deployment. So to a certain extent, based on objects and transactions, our system under load actually gets faster because we start cutting blocks quicker as we fill each block, right, which is obviously pretty standard. But we don't have a hard multi-minute return on any I/O. It's sub 4 seconds. 4 seconds is a worst scenario. Under load, it gets faster because we're cutting blocks quicker, right? Now, the upper ceiling of that, is going to be an interesting place to find. But under the type of workloads that we've tested against and we're actually in production against, we're well within our capabilities. And obviously, by the nature of distribution, there is, there can be latency, there can be access requirements. The actual, if you think about the total, transaction, the actual any type of the I/O latency is a very small percentage of that, the type of transaction that we're dealing with.
Well, it sounds like you solved a lot of problems out there that are plaguing most, permissionless public blockchains, for sure.
Yeah, I mean, obviously the removal of any type of proof of work, and the Hyperledger, I think, initiative has kind of done that well. You move into a consensus-based model, but I've got some very clever guys on the team like Ruben Thompson and Nick Mellis. These guys have been, involved in this kind of, I/O and kind of data transactions a lot of the careers. So we're bringing to bear a lot of what we've learned over the last kind of 20 years.
Why do you call it gospel tech? Are you guys preaching the Hyperledger gospel, or where the name comes from?
No, I think we've actually, Hyperledger. Hyperledger was the thing that got us going, but we've realised we've had to build a lot in our application, and we've moved away somewhat from core Hyperledger. But gospel, is really about the truth, and I think that if an enterprise or a business has the ability to create a known truth across their data and across the identity and the data they consume from other businesses, that truth creates trust and speed. And I think that all businesses are going to differentiate and become successful based on the ability to operate at speed in this, kind of cloud native digital era. And speed is really what we're looking to achieve, not in terms of, how many 100,000 IOPS per second can you achieve in a memory optimized data structure. It's more about, how do you remove the latency of, humans or people or systems within, between the business processes, between the applications and the machines and the systems that are actually building your business. And that's where real business latency is. And I guess that's what we're trying to achieve, and that's what we've, achieved very effectively in some of our clients. One example I would say is that, we've worked a lot in, automating, the procurement cycles and of kind of distributed devices. So traditionally, if a motor or a component fails in a machine, that usually would have to kind of fail, and then once failure had occurred, there'd be some sort of downtime, and then an engineer would go and kind of look at the part, they'd order a new part would come in, maybe there's a spare that would be replaced. That's kind of manual, slow process to ensure availability of that platform, of that manufacturing system. What Gospel does is through APIs, it natively connect through an IoT platform to that machine. So Gospel is actually starting to have a provenance of operation of the machine, of the part. Even before the part fails, a request from the IoT platform going to Gospel in real time can do price matching, ordering, automated supply chain, and delivery of that component, actually meshing together a number of different procurement systems in the vendor, in the supplier, in the distributor, in the delivery system. And all of those elements are engaging on that workflow, ensuring that everybody is operating within a trusted bubble, and that part is delivered before the existing one even fails. So Gospel starts to become this common platform where data can operate and be consumed in a trusted way, rapidly accelerating that business process, removing any potential data leakage and removing any human error, or indeed any human error that may be forced because of a hack or an attempt to leak or breach. So it's think about business latency. Gospel massively reduces along with risk.
Very good. What's on your roadmap for the next 6 months or a year? What's coming that's new?
Yeah, look, I think that this space is rapidly developing. Our roadmap is out for the next kind of 12 months. We have our 2.0 platform in production at the moment. 2.5, which will kind of be released in the next few months, really is starting to bring a much more robust security and encryption capability, as well as much better interaction within existing enterprise data structures. So what we kind of focused on in these early days is, rather than trying to build, a new silo, a new island, just because it's based on blockchain, we don't want to replicate kind of the existing data silos. We're focused on the ability to natively interact with existing enterprise security and data structures. So we've done a whole load of work on interacting in source data types like traditional databases, like maybe Oracle or SAP structures, anything kind of, ODBC, and these kind of like source data structures, whether they be, CSV files or unstructured data. We have the ability with our Ledger Bridge technology to rapidly bulk ingest and cleanse that content onto Gospel. So, one of our early value propositions the client sees as they deploy Gospel, they can kind of clean up and bring data onto the platform in a format that makes it eligible for valid transactions, removing duplicates and cleansing that content. So a lot of the work we've done and we've focused on is that, elegant and native interaction with those existing enterprise technologies that are kind of trusted and used on a daily basis. Second thing, I think on our immediate roadmap, which is huge, is really around a lot of changing legislation. We've seen a huge amount of kind of government and regulatory attempt to kind of get control over some of these new models for business. So open banking is a kind of an example where, your financial organization needs to be able to share your data, and to do that, it requires consent. And then we've got regulations such as this general data protection regulation coming in Europe, and it's all around, the control of your personal data, where it sits, the right to be forgotten, consent again. And, what we're really focused on in the next 6 months is delivering, enterprise grade technology that allows very clear and consent and control over how that data is shared and used, and how you can withdraw consent and actually then create that removal of that data from any existing systems it was in, or existing systems that are actually viewing it. So I think that, very clearly over the next 3 to 6 months, we'll be bringing a whole load of more of that native enterprise connectivity and, a lot of compliance and regulatory technology and capabilities, giving them much more secure and trusted control over consent and data access.
Yeah. Last question. Do you think that the companies that are working with open, permissionless blockchains have anything to learn by talking to you and looking at your technology? It sounds like it, but I don't know if they would do that.
Listen, I think that you get into some very passionate views, which is fantastic, and I think it takes passion to drive this kind of industry forward. And I totally see the value in both, unpermissioned distributed structures to, create, these highly distributed kind of models. But I personally also see a need within smaller groups internal to business, across multiple businesses, between different business units in a manufacturing process or different units within a military organization. I see the need for a permissioned environment where you don't need the really energy inefficient processing and the highly inefficient infrastructure to generate trust. I believe there's already within business a whole set of multi-factor capabilities to guarantee and authenticate the actor. But I do believe that doesn't go far enough to the actual point in where the data needs to be secured and accessed in a distributed model. So we believe the application of blockchain architecture into an existing permissioned environment it creates a increased data security capability that allows businesses and these permissioned kind of structures, whether it be a business relationship or a client business relationship or, multiple businesses operating on a single collaborative program, that still, it becomes much more efficient using Gospel. Now, whether people think the whole concept of the permission blockchain is, totally against the, philosophy of, the underlying technology, well then, okay, I respect that opinion, but, I see what we're doing as a need to control access and remove some of that inefficiency and that infrastructure inefficiency to kind of get work done. very much depends on the use case of the technology.
Well, very good. So what's the best way for interested parties to contact you? Email, phone, etc., website?
Yeah, I think we're on the web, gospel.tech. We're we're a UK-based software company. Plenty of ways to contact us. I would suggest our general email address, step.forward@gospel.tech, is a good way. And we look forward to kind of engaging in discussion and talking about what we're doing in production with our customers, right?
Well, very good, Ian. Well, thanks for coming on. And I see a lot more of the merits now of the Hyperledger protocol and similar ones than I did before. So thanks for the explanation.
No, you're very welcome. I think what I would say is we're all learning, and there's all a lot to learn. It's an extremely exciting space, and we're very proud and excited to be a part of it and pushing it forward. So thank you for the opportunity to talk.
The Bitcoin, Ethereum, and Blockchain Super Conference is coming to Dallas, Texas, February 16, 17, and 18 in 2018. If you know of a better way to get the latest insider knowledge about crypto, to hear directly from the top minds in this field, to interact personally with 800 fellow crypto lovers, hodlers, investors, miners, traders, developers, and founders, then I'd like to hear about it. If you don't, then you don't want to miss out. Register today for the Bitcoin, Ethereum, and Blockchain Super Conference. Go to bitcoinsuperconference.com and register today as a super early bird to get the lowest rates on tickets and hotel rooms. That's bitcoinsuperconference.com.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.